Hello everyone. Today we are going to present the capstone project of electronic circuit and electronics subject. Our team consists of me, Onwara Kancana, and Mr. Thirawat Bunsang. Let's jump in. Okay. Our first task is to create a 30-volt regulator, which is its essential components are resistors, potentiometer, electrolytic capacitor, transistor, and diodes. On the figure above, shown a schematic of the regulator on a Proteus software, and the below picture represent the actual board created. Here is the brick rectifier part. It's composed of four diodes, and these four elements plays an important role in this circuit, which turn AC to DC. The AC voltage will give output voltage as positive and negative, which we want it to be positive to be able to use it. So with these four diodes, we can divide it into two pairs. One will allow only the positive and another one will allow only the negative to pass. Anyway, both of them will end up as the same output as shown on the right side. The first figure from the top represents the original the voltage, or as an input in this case. Then after passing through the bridge rectifier, it will be like the last picture that all the voltage will be on the positive side, but still not good enough for us to make use of them. So let's go further to the next slide.
The 1000 microfarad capacitor is connected to be a smoothing capacitor. By discharging current, it provides a smoother DC voltage output from the diode bridge rectifier. The result is present from an experimental circuit simulation on graphs at the right-hand side of the presentation. The first graph presents the 5 microfarad capacitor, which has an output gap of 3.6 volts, while the 50 microfarad capacitor has higher at 7.9 volts, which means a smoother waveform. It also means that the higher capacity of a capacitor provides a smoother output voltage waveform. Nevertheless, the higher capacity of capacitor requires a longer charging time. This is the DC voltage regulation part. It functions to regulate the DC output voltage by adjusting the 10K potentiometer. The reservoir capacitor is used to rectify voltage falls from an output. It acts as same as the smoothing capacitor that we mentioned about it before. In this case, we use a 47 microfarad capacitor that functions as a filter to reduce output voltage ripple and unstable voltage waveform. This is the video present how the variable regulator circuit works with 12 AC voltage and 50 Hz input. The DC output can modify by regulator resistance at 10K potentiometer. The second circuit that we want to present is the DC motor speed control, and this consists of components on the right-hand side which show on the presentation. For this slide, present the IC 555 pin schematic and block diagram. The IC 555 is the IC that is the main components of our DC motor speed control circuit. There are three operating modes for IC 555: bistable, monostable, and astable mode. But we will focus on the astable modes for our circuit. The IC 555 is an unstable mode. In the beginning, the IC capacitor is charged until the voltage reaches two-thirds of VCC. At this time, the output voltage is high, or in a digital signal form is 1. The C1 capacitor is discharging until it comes one-third of VCC, which also triggers the output to be 0. After the voltage of capacitor reaches one-third of VCC again, it will continue in cycles like this, which represent the chart represent on the right hand side. From this, by changing the resistance of the VR1 variable resistor, we can modulate the duty cycle of the PWM, which we will talk about this later on. For the on and off time, total time, and the duty cycle frequency can be calculated by equations on the right hand of the presentation. PWM. The PWM, which stands for pulse width modulation, can generate um, variable voltage by turning on and off at very fast rate. It is used to control the speed of motor by changing the signal's duty cycle or the amount of time the signal is on and off in a single period of time. For the additional components part, we would like to focus on three components. The first one is the C2 capacitor, which we connect the to the control pin of IC535 to 0.01 microfarad capacitor to eliminate external noise that may come from the terminal. Second, we add C1051 transistor to drive a motor and handle the motor's current. Third, between the output of a circuit, we connect the N001 diode in parallel with the motor to operate as a flyback diode for preventing any voltage spikes generated by the motor. This video presents the simulation of the DC motor speed control circuit on the produced program. By adjusting the potentiometer, the speed of a motor is changed.
Finally, we come to our final outcome or actual project that we have made. These are the main components of the overall circuit. The switches, actually the other switch supposed to be the slide switch so that we can choose between 12 and 24 volt. But for safety concern, 12 volt is enough for this take-home project. So then we have used a fuse, transformer, variable regulator, DC motor, speed control, and DC motor. This is the overall schematic simulation of the previous slide. Let's see.